When modern 3D printing was invented in the early 1980s, few could have predicted the influence it has today. At no other time in history has it been this easy to transform a sketch into the real thing. And while that feat has proven immensely useful for constructing complex machines, it is unlikely more meaningful anywhere else today than in the field of biomedicine. With the ability to churn out standard or custom prosthetics, devices, and even test models, the 3D printing of biomaterials is revolutionizing medical care. One of the greatest conveniences afforded by biomedical 3D printing is the ability to manufacture parts on demand. Common load-bearing prosthetics, such as those for knee or hip replacements, no longer have to be built in bulk and benched before use. Virtually stored print files can be called upon and processed into parts as soon as they are needed in the clinic, with the printing material and methods suited to the part's function and placement. There are electron beam or laser-assisted techniques for metals, extrusion methods for ceramics and polymers, and inkjetting and lithographic techniques for composites. Of course, custom jobs can just as easily be queued up. When physicians can't simply reach for their virtual shelves of standard parts, they can resort to gathering patient-specific data. Body scanning techniques such as CT or MRI can provide templates for drafting custom grafts, such as for bone in the case of a complex fracture. Interestingly, one of the areas making the fastest gains in biomedical 3D printing is the manufacture of parts that will never find their way into any body. As printing techniques have reached increasing levels of precision, they've evolved to the ability to produce hyper-realistic models of surgical sites. Budding surgeons need not be limited to 2D drawings or cadavers as they set out in their career. And seasoned veterans can safely interact with 3D printed replications of areas that require an extra delicate touch, such as a precariously situated tumor. Even as 3D printing has progressed beyond the predictions of its pioneers, many more applications are in the making. Some researchers, for example, are printing rudimentary parts with biological material or cell-loaded inks called bioinks. Though much work remains to be done, 3D printing offers a promising future for biomedicine. As the field continues to advance, new patient treatment options are expected to become available, allowing medical care to flourish in ways never thought possible. To find out more, read the article Clinical Significance of Three-Dimensional Printed Biomaterials and Biomedical Devices, published in the June 2019 issue of MRS Bulletin.